So basically, right, the idea is just to wet it up a little bit, but you don't want to wet it too much because if you wet it too much, it's gonna become too soft, right? Okay, so we want to use a little bit of water. We got plenty of tables. With this one, this other ones, okay. Okay, so yeah, we're gonna definitely need more than one. I've done this probably with the 3 years ago last batch of students, but I'm not sure. I'm not sure if it will still work with this batch, but we can always hope for the batch. Did you work the last time? The last time was 3 or 4 years ago, if I'm not mistaken. Did you work? Yeah, it did. It smashed right through. Take it on the tissue. That's the tissue. Sad you and funny. Thank you. Okay, guys. Make it a bit sharper. Let's start with 3 first. Okay. The fun police is here. Okay, I think this should be enough. I think. Who wants to smash it? Okay, guys, do you think this is going to penetrate right through or not? It's not going to smash into 1,000 pieces. Don't worry. Okay, but first drop. And because I'm applying force also, I'm not letting you know, I'm smashing it down. Okay? Just take the iPad away from me. Okay. 1, 2. No. It's dripping already, boys! And if I carry it right out, wow, that's water dripping for sure, guys. It actually went. What the hell? You missed the coconut session? What the? Recording. But luckily it's recorded already. You see this? It's already going through already. Want to shoot through here now? Okay, let's do it one more time. Okay, guys. I'm gonna need some more tissue, guys. But hey, went through again. Oh God, now I made the biggest mistake of my life. Both sides. Hey. Sideways. Sideways. Okay. Wait. Can someone get me a cup or not? Hey, go to the kitchen and get me a cup. Oh my God, this thing is like, it's like leaking like crazy already right now. Okay. One more. We try the green color side, okay?
The green color side is so thick though.
But with the application of physics, nothing is impossible.
Let's take one more around.
Drip, this will take for us. Okay, just smash it again. All right, Michelle, smash it. Yeah, the side. Okay, let me take I guess there was a good idea to sit a bit further away. Okay, smash it right through, okay? And smash it right now. Okay, one more.
Oh, maybe this is too much. I thought you are good at showing coconuts, man. 又漏水啊！
又漏水了哎 ，what the hell？
这么软的吗？
它开始软了 ，Oh my god， 不可以了，it's too wet already now。
对
Okay, alright. This 谁要喝可乐？等一下。
，so dirty, what the hell?
Nah, it's not dirty. I'll drink it first if you want. 我已经喝的这个 is clean 了。
Wait, so you come here through the green light?
I think can if the application is correct.
Oh, this is good. Yeah, that's like slightly.
Bottoms up, boys and girls.
His fingers in that. How do you feel?
Refresh lah. What else?
你想表示尊敬你看第二杯啊
Mishan.
？Cause you feel the fucking smash，但是它 drink the water。它漏很多。
It's a good coconut. 对啊，差不多没有
No
了。
no no， 我还以为你要讲你上的 coconut 是最好的。
Okay.
那个边。
Oh my god.
边
Oh my
大
god,
小。
no.
Oh my god, the cupcake Vicky want to get electrocuted.
我这口水了。
这 coconut 流不停呀。
Tissue there, wait.
我等
Oh
放
my
了。
god.
Oh my god.
怎么这个 coconut 那么多水的？打折买一个小一点呢
Did you like buy this at the market?
？No, I passed by this coconut shop. I'm like, hey, uncle, boleh ambil satu coconut lah. Then he's like, nak tapau ah? Bukan, nak the whole coconut.
Okay lah, Natalie, just leave it lah. Then he wants it. He's having all the fun.
Okay lah. Okay lah. I think this one here is one last smash already ah. All right, this could end in either penetrating through or I'll smash the table so hard that the coconut is going to break.
Oh, another layer.
Okay.
I think you get the cups off first.
Oh,
Move the cups first.
I almost smashed it with the cup there. Oh, 加了一个。Hey, who wants to drink? Okay, I think it's finally done already. 有两杯 full 的，但这桌子上面的还没有。Okay, make it like one more layer，给它剪了一点点。Okay, who wants to smash this? You gotta like smash it like someone did wrong to you, you know, like 他骂你爸爸，骂你妈妈 then oh my god.
Imagine the child.
Whoever it is. So you smash it right down, okay? Oh my god.
Brian in the class.
Right?
Is it showing?
Hey.
Hey.
Good job. I thought you're not supposed to eat beef.
1, 2, 3, smash right down. It penetrated through a little bit, but maybe you see the top all come up already, you see? It's penetrated through already.
Oh.
So yet again, with the power. Oh my god, 你的袜子应该是试完了。
Nice.
But through the power of science, I just want to tell you that
It's leaking.
Okay lah. Okay guys, now I want you all to help me do me a favor, okay?
Wipe the table.
Help me wipe the table.
Nah.
Anyone wants to drink this? Seriously. Hey, don't worry lah. 喝不死你了。
You drink.
I will. Cheers.
Cheers.
Yeah.
How are you actually planning to clean all of this up? The chair also wet. Yeah, and your table is also wet.
Just like the power of physics, we will be able to get through anything together.
You see, it's in.
Which is okay.
Clean out the wire, the resistance.
Okay, someone help me walk to the way first. I need to throw this shit away.
Just in the trash like that.
这个你先吃那个东西是coconut味道的。coconut and meat 味道。
Cold rubbish bin is like filled with coconut. Yeah, I probably woke up.
正到一样的，
Oh,
一样的 number。
Just
Just a number like
Sure, they just
1 to 5 啊。 If you really say that.
你们两个先啦，先开始讲 ，What's the phrase？
Yeah, more than.
1 to 10，
为什么？
假如
That's a very good question. I don't know as well.
你讲过
Ask your brother where's the ball.
It's not gonna.
我通到7 to 1 7 to 1
Oh my god.
Using
真的
so
太多水
many
了。
tissues.
You
Bowl,
really need a bowl, eh?
this is a bowl.
假如
哎呀歪的
如果一样的话，我是的，你两个人一起走。
Let you wipe the trash.
That's
accident. No, this is better. Oh.
你就是没有标出
I wasn't gonna go out with milk chewing gum, please. You wanna try?
You only one answer.
Shan, is the coconut water minty?
I think.
You drank?
Normal coconut water.
Man, you're using so many tissue, it's bad for the environment.
Oh well, I guess I'm sorry to the next generation, but oops, I don't have children. Oh. Grace 啊，所以说要这个
Why the table be so sticky if you don't even
Yeah,
use it?
I need to do that. Oh well, this is what happens now. Oh my.
Answer 喜欢to 玩火。
火 Okay, you stay later. Wait a second. That's your all the Oh yeah.
Scan 到我。
Okay, okay. After class we play, okay? We take IMAX time to play. Oh shit, 今天不可以，我要赶回去，我有一个下个礼拜 ，OK， 下个礼拜一定完 ，promise 你们，下个礼拜那个打火机还在那边。
哎呀，肯定嘛。
哦，哎，这个 expert 他可以做你的 game master 这礼拜。
It burn their brows.
It's someone's
Yeah.
someone. Yeah, last week game was so funny.
Yeah. Crispy and curly.
Yeah.
Crispy. It's crispy. She's like, oh my god. And then I got burn and there was fire on
Yeah,
it.
maybe I should have done this in the classroom way. Now that I think about it. But mistakes in life, guys. And look at all this tissue paper that we have wasted. And oh no, 谁要死这个干？米山。Oh shit.
Oh, all people in
He's sticking here already. Hey, Mishan, I arranged for Kenny to come on Thursday as well already.
For the next Thursday, I cannot go.
Yeah, starting this Thursday. Oh, yeah, our next Thursday is yeah. Hey guys, anyone here that wants to take mathematics? We're restarting the physical class as well already. So yeah, but I think most of you guys that take at maths won't. Hey, 帮我拿去后面我这个真的。There's too much shit to clean here. Eh?
It was a mess. Yeah.
Hey.
Yeah, exactly.
Oh my god.
Yeah.
Oh.
What was that?
Let's see.
And don't forget the front part also. The front was also bad. Front part also. So here, here.
Ah, regrets. Regrets all day long. Hey, you know what? What's gonna happen? You cry later when you set on the floor like that. 做咩咁黐立嘅？
有。可以啊。
嗯。Okay, that's it already.
The center don't have more fun.
Yeah, I also don't know where the mop is right now, honestly. We wasted the whole tissue roll just to mop the table and the floor. Half a tree. 有誇張冇half a tree 啊？
Imagine your children.
Sorry, they all have to see trees from the storybooks already. Okay. Can you pass me my laptop? Thank you, thank you. All right, guys, and with that, we continue with today's class. Oh, okay, guys. Yeah, let's start off with this week's chapter, guys. We're moving on to a new chapter this week already, guys. So please make sure you ask if you don't understand anything that has happened. Please open the pen already. Not Apple pen. Oh yeah, who hasn't gotten their notebook yet by now? Has everyone gotten the notebook? I ordered 2 more. I think Abigail. Hey, Marcus, who do you pass to? The day I asked you to pass some of it.
You got pass to me, man?
Me. 你有吗？那本书？你拿带哪里？你来 class 你不带 notes 啊 ？Okay, for you, can you pass her more of the notebooks and exercise book? Pass it to her. Hey, where's the rest of the students' advice? Huh? Who ordered Grab or Foodpanda? Gilbert, is it? Ask Gilbert to come get it. Okay, guys. Flip to this page here, wait, from the notebook. It's at the end there, towards the end, radiation. Yeah, one more page. Shani, is it? I thought you left. I'm like, didn't I just see you here?
Yeah.
But you didn't miss anything. Okay, guys, let's continue with this chapter, guys. Basically, we're moving on to the final chapter, which is radiation physics already, guys. Like I mentioned over and over again, once we're done with this chapter here, once we're done with this chapter here, we're going to go through revision already, guys, and then we're going to focus a lot of our time on past year papers because, quite frankly, at this time, theory means nothing already. It's answering, which is going to save you guys. Okay, guys, so let me just give you a run through of what you're supposed to learn today. Guys, you're basically going to learn about the 3 main radiation sources, which is mainly alpha, beta, and gamma, right? Depending on alpha, beta, or gamma, they all have their own key characteristics, guys. Now, in your syllabus, the only 3 radiation that you should be focusing on is obviously alpha, beta, and gamma, all right? So alpha particles, you can kind of consider them as like positive radiation. Their nature is positive by nature. Beta is the negative one, and gamma is the one that is neutral, okay, guys? Now, hey, don't copy anything of this down first. I'll give you guys some time to copy. Please pay attention first. For detection-wise, guys, different materials will have different forms of, different radiation will require different forms of detection. If you look at the detection for the alpha particles, you see that it is detected using a cloud chamber, whereas beta particles are detected using a Geiger Muller tube. What does a cloud chamber look like? Let me just turn this on for you guys. Wait, cloud chamber alpha radiation. Guys, if you
most likely none of you guys have ever seen a cloud chamber before, right, guys? A cloud chamber is basically something that you use to detect alpha radiation. This cloud chamber is basically a very small petri dish only. It's something that you see in your experiment. And essentially, if you look here, right, guys, if you see this white color thing here, this is the source of the alpha particle that is emitting out, guys. So if you look at this video here, you'll notice that the alpha particles, when they are being shot out from the source, it kind of resembles like a fighter jet flying through the sky, guys. It'll leave clouds of traces of clouds at the back here, guys, and this is what we call a cloud chamber. Usually, alpha particles are detected using these cloud chambers here. Okay, cloud chambers here. Right, and the what's it called, the travel distance of alpha particles are generally very, very small. Even though this video may seem like it's big, right? The actual size of it is probably this big only, meaning to say that alpha particles can only travel a few cm away from its source only. It is not going to travel anywhere further than a few cm away. Okay, so this is essentially a cloud chamber. Okay, you can see that. Every time the alpha particle is emitted, it kind of leaves like a trail of cloud behind, somewhat resembling like the fighter jets that you see in the sky, guys. So every time we're thinking about detection, cloud chambers can be used to detect alpha particles here. Okay, and then yeah, it's just the same thing over and over again. It's like continuously spitting out alpha particles. Here's another experiment that we'll explain a little bit more later on. But the second form of detection of alpha, beta, and gamma is something known as a Geiger Muller tube, guys. But oh, some of it is going to pass through, some of it is not. Have you guys learned this in school already, the GO4 experiment? Yeah, since most of you guys have learned this, I'll let you know what's happening here, guys. This experiment is also very, very famously asked in your IGCSEs. Out of the 10 years, right, at least I see 3 years asking about the GO4 experiment. In this GO4 experiment, right, they will usually use alpha particles shooting through these GO foils, okay? And what they notice is that, right, as soon as the alpha particles shoot through this GO foil, you see, some of it, actually, most of it will actually penetrate through the GO foil. Some of it will deviate to a different angle. Some of it will deviate to a different angle, and some of it will be reflected back at a much larger angle here. Wow. Oh my God！ 怎么你在这边？啊，这个是我的 ex student， 我的黑马来的。进来的时候 just derping around， 可是到最后考 A star 的。哎 ，thank you，thank 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 you。哎，你是等他走是吧？
没有，
你载他来啦？
没有在。
嗯。是啊 ，check eye 嘛，最近。Thanks, Aloy. 我们再 contact on Instagram. Bye. Okay, guys. So what's happening here is, right, this GO4 experiment not only proves two things, guys. Number one, the reason why most of the alpha particles they shoot through is because there is a lot of empty space in between them. And number two, which usually is asked in your IGCSEs as well, it proves that the nucleus is where all the charges are, guys. That's why most of the alpha particles that shoot inside will be reflected backwards. But this is not a good enough video to explain now. I'll show you another video later on. Okay, I'll show you another video later on to explain how the GO4 experiment works. But for now, just look at the other thing, guys. This Geiger Muller tube. Oh my God. Animation. You need the stupid sound. Okay, this Geiger Muller tube, which you don't need to remember the full name, guys. You just need to remember that it's called a GM tube. You know, like if you ever watch Monster Inc., those guys that take that they wear the white yellow color hazmat and then they go like that kind of scenario, right? That gun, right? This is that gun, guys. It's called a GM tube, which is essentially used to detect many forms of radiation, including alpha, beta, and gamma. Okay, so every time you see like all the movie shows are like with the yellow hazmat on, that is essentially a GM tube. The full name is called Geiger Muller tube, but I can say no one remembers the name. Just remember GM tube, which is asked in IGCSEs. They'll ask you what is used to detect alpha or beta or gamma, right? If it's just alpha, usually cloud chambers. If it's beta or gamma, That is usually GM cubes. But GM cube can detect alpha radiation as well. And the symbol will look something like this. This is something that you see in your laboratories, right? But probably not in high school, probably in university. But yeah, this is the thing that detects. This is a mini version, right? It even has the word mini there, right? Which is obviously what it does. And the symbol will look something like this, guys. You'll notice that it kind of resembles like a cathode ray or whatever. If your school is still teaching you guys about cathode ray, your school teacher obviously is wrong. It's not in your syllabus anymore, guys. If you see any past year papers later on when you do and you see the word cathode ray, right, ignore it. It's not in your syllabus anymore already. Okay, everyone, this is just like a graphical representation. So you have an idea of how a GM cube looks like in your head. Okay, but you'll never be asked to draw this because obviously this is not arts class, right? Yeah, and moving back here. Oh God. Hey, something is wrong with Zoom recently. Every time I switch from window to iPad, always they need me to re-download this everything again. Sorry? You don't have to care at all. All these things is just to like detect the thing so that the radiation comes through it, a mica window, but you don't need to care at all. Like it's not in your syllabus at all. Why is it not going in? Oh, fine. Okay, so going back into here, guys. Going back into here, obviously, like I mentioned just now, the things that could detect alpha is cloud chamber, something you saw just now, and the GM cube, the Geiger Muller cube. The symbols for alpha, beta, and gamma is wrong, right? The alpha particle should actually look something like this, guys, the symbol. It looks like an A with a tail. This is basically a B with a tail, and then this symbol here is basically the Cancer sign for women. You know, you see like all the Cancer symbol. No, I mean, I'm not trying to be funny, but this is really the Cancer sign. You guys know, right? A lot of all the cancer awareness stuff. This is the symbol for it, okay. Guys, sometimes in your IGCSEs, they will not indicate the full name. They won't say alpha, beta, or gamma. Sometimes they'll just give you these symbols. And most of the time, I notice that the students, they get really confused when they see this symbol here. What the? They see this symbol here, guys. Remember that this is a gamma, because I think alpha and beta is very easy to see, right? But when they see this symbol, they're like, what is this? This is basically the symbol for gamma radiation, guys. You must know this, yeah. All right. Then after that, depending on which type of radiation it is as well, everyone, yet again, don't copy down, listen first, right? Depending on what type of radiation it is as well, it has its own elements, guys. The alpha particle is basically a helium-4 A beta particle is basically an electron 0, -1, and gamma, there is no element in it, because if you recall, gamma is part of the electromagnetic spectrum, guys. The electromagnetic spectrum, meaning to say this gamma radiation is actually an electromagnetic wave, guys. If you recall, right, ringgit Malaysia is very useless, no good. For those who are a bit late, you won't understand this. But for those who cannot remember the electromagnetic spectrum, let me tell you a quick story. Ringgit Malaysia is very useless, no good. Then you can remember the whole spectrum already, right? The story is basically because when I graduated in 2016, our ringgit was plunging like hell. Was it 2016? Probably 2015 or something. I can't remember, but long time ago, not that long ago. My ringgit was plunging like hell because of our dearly beloved Prime Minister, Najib Kaur, right? So because of that scandal with 1MDB and of course the fat Jolo, right? Our ringgit plunged like crazy to 4.4, and then we thought like that was the end of the world, but who knows, we survived that and then went back to the end of the world right now. If you read the news a little bit, our currency has dropped like crazy yet again because, you know, Malaysia, right? So from here, right, ringgit Malaysia is very useless, no good. Radio, micro, infra, visible light, ultraviolet, X-ray, and also gamma rays. Guys, gamma ray is part of the electromagnetic spectrum, and thus it doesn't have any element. It is just a ray, guys, and to be more specific, it is an electromagnetic wave, right? So like I was talking just now, basically we can always remember alpha, beta, and gamma as positive, negative, and neutral because of the charges they hold, okay? Alpha particle is positive 2 charge, which obviously can be seen from the element itself lah. The beta particle is negative charge, negative 1 charge, which is yet again seen by the element. And of course, gamma rays, they have no charge, they are neutral, meaning to say they don't have any positive or negative charges here. Okay, now I want to highlight one thing, guys. If you notice here, guys, the charges is actually directly related to the word ionizing, guys. Anyone here don't know the word ionizing or not? What does ionizing mean? Do you guys know? Okay, if you don't know, right, ionizing is basically the ability to steal positive or negative charges. Okay, if you ever wondered why radiation is so dangerous, it's because radiation is a form of ionizing charges, meaning to say, let's just say, for example, today, if I have a helium particle, which is obviously positive 2 charge, right? If I beam helium particles to your body is by right neutrally charged. Neutrally charged means to say as positive, and negative. They are all balanced off, right? New chapter, because this is positive 2 charge, it means to say it has the ability to steal 2 negative charges from you. Meaning to say, if let's say my alpha particle is being beamed to me, right? What's going to happen is it's going to steal 2 of my negative charges. These 2 right? Meaning to say these guys become poor themselves, and when they become poor, what's going to happen? They're going to steal from other particles, and then this one will chain reaction, and then this one will chain reaction, and chain all the way, which makes it very, very harmful, right? That's why you see this is a speculation. It's not scientifically based, guys. It's speculated by yours truly, right? You know, like all the radiation cartoons, you see like when they are beamed with radiation, you see like the cartoon characters start melting away, right? Have you guys ever seen that, those kind of cartoons before? Or you guys have no childhood? You know, like in cartoon, when you're exposed to radiation, your body will melt away, right? This is a speculation. It's not backed by scientific things. But the reason why the body melts away is because the charges keep destabilizing. This guy is going to steal this guy, this guy is going to steal this guy, this guy. So it's like liquid flowing downwards already, you know, because of the chain reaction. And this is only when one positive charge is here. Obviously, when you're exposed to all this radiation, it won't just be one alpha particle, it will be like a gazillion of them, right? And if you have a gazillion of them, then your whole body is going to be basically fucked up, right? So don't play with radiation. You know, like, do you guys watch The Simpsons? Anyone here? The Simpsons, right? You know, Homer is always playing with all this radiation, right? You know, in history, right, there were 2 people that actually held all these radiation bars before, you know. On the first day they held it, they didn't think much of it because it was a glowing stick, right? It was a glowing stick, and then they held it, no problem. They even passed it on to the kid to play around with it. Let me tell you, all of them died. They all died because exposure to radiation is no joke. Definitely everyone is going to die, and it is a bad thing, guys. So, you know, like Nagasaki, Hiroshima, right? Boom, everyone died. You know, that kind of shit. And I've read some document online as well. You know, the bomb was so devastating. You can't just close your eyes and like don't see the flash from the bomb. You know, all the soldiers were instructed to lay down like this. And even when they lay down like this, right, when the bomb went off, they could literally see through their bones, you know. That's how strong explosive radiation is. So definitely stronger than Jesus, man, I tell you. With the power of science, anything is possible, okay? So, here again, science wins. Yeah, seriously, it's like the radiation was so much that they flashed right through their body. And it was like an X-ray vision for that instance only, right? But of course, this is hearsay, which from the document, right? Please do your own research. But I don't think it's hard to believe because it was a nuclear bomb and it was definitely not here to play around. Anyways, looking back into here, guys, ionizing radiation, you'll see that they are either very strong, very weak, or very, very weak, right? Why is it very strong? It's because alpha particles can steal 2 negative charges. Right, beta particles are relatively weaker because they can only steal 1 positive charge, whereas gamma particles are very weak. They cannot steal any charges at all. Whenever you see the word ionizing, it's basically the ability to steal positive or negative charges, guys. All right.
So we have less the column here.
Oh, really?
We don't have range.
Oh, never mind, add it on later on. But anyways, once you understand the ionizing part, which is the most important thing, guys, ionizing part is when they ask you the most things in your IGCSE, they'll ask you which one is the strongest ionizer among them all. You're definitely supposed to say alpha. Why? Because it has positive 2, meaning to say it can steal 2 negative charges. Beta is weaker because it's only -1. It can steal 1 positive charge, and gamma is speed of light. Hey, but I asked you not to copy first, right? Oh, pay attention, right?
Wait, is it like the only reason, or is it also because like slow and then exposed to more particles?
Sorry, what?
The alpha ray is very strong ionizing because like it moves slow.
Oh no, it's because the element itself is large already. Okay, so moving on, guys, pay attention here. You see that the mass here of alpha is 4, beta is 1 over 1000 or something, and gamma is 0. Why? For you have to remember this, guys, alpha particles is the heaviest among all of them simply by looking at the element, right? I mean, you look at the element, what is it composed of? It's 2 protons, 2 neutrons already, right? You want to ask something? You know, stretch coming. Right. So looking at the element itself, you know that it is the heaviest, right? You don't have to remember the number 4, but you have to remember the alpha particles are the heaviest. They will ask you this in your IGCSEs. Now you're going to say that beta is definitely much lighter. Gamma has no mass because gamma is an electromagnetic wave, guys. It is essentially a photon. It does not have mass at all. Okay. Now, of course, the range-wise, like I mentioned, alpha can only travel a few cm. Beta is further, and gamma is unlimited because it's a wave, so it can travel anywhere, right? And from here, you can see the speed that alpha is obviously the slowest. Why? Because it contains the most mass, guys. Not discriminating, but it is just the way it is. If you are relatively heavier, you generally cannot run much faster, okay? Whereas beta, you are almost the speed of light already, guys. This 0.1 means to say it's 10% the speed of light. 0.9 means to say it's 90% the speed of light. And gamma is essentially traveling at the speed of light because, like you recall, all electromagnetic waves travel at the speed of light, guys. And ionizing, weakest. Okay, guys. Any questions or not for this part here? All these characteristics will be asked. Yeah. Everyone already done copying, I assume. Everyone not done copying.
How did they like make up the support? Those not the white color thing where the source of alpha ray, the alpha ray. How did they like make it so that they only release alpha?
Because the source is only an alpha radiation, like the source is only alpha, so it can only emit alpha particles. You get what I mean?
How did they actually know that?
Well, how do they know? Rigorous testing for sure.
The rest is gram, right?
No, not grams. It's just the relative charge only. It's definitely not going to be 2 grams. One alpha particle is like a very small speck, which you cannot see. It's an element. Yeah. Okay. Shani, how was your event? I saw a lot of posts from there. Okay, everyone, done copying? Oh.
They're like, seriously? 1 year? Can you go down?
No. OK，會欣，尋晚中意邊度？你偷雞啊？定係？Or you're like the Kanta guy? How food. You see the news, the Kampa guy he goes steal the man's underwear and then put it in the pocket and went home. What the hell?
Men's underwear.
I mean,
What the fuck?
if you want to steal, at least steal the girls one, right? If you're a guy, why are you stealing the guy's underwear?
I don't know.
He's a perverted gay guy. More cheeky.
Where was it?
It was in Kampa. Yeah. Hey, that drawing. Hey, I mean not drawing, writing. I want to explain the drawing part, guys. Now, this part here is essentially the most important part, guys. Pay attention. In terms of penetration, guys, you must know for a fact that gamma particles they actually penetrate through the most, guys, where alpha particles are the weakest. Alpha particles are so weak that once you block it with a piece of A4 paper, the alpha particles cannot shoot through already. Meaning to say, if you recall back from the video just now, the cloud chamber, right, the alpha particles were shooting straight, right? If you just put a paper in between the source and the cloud chamber, it will be stopped by the paper itself already, guys. Alpha particles have the weakest form of penetration, which can be stopped by literally anything in between them. Beta particles will, however, be stopped by relatively thicker aluminium. How much thicker? Probably somewhere around 5 cm. In your IGCSEs, if you see the word like this something is blocked by aluminium, it means to say most likely it's going to be beta particles. And in your syllabus, besides aluminium, they like to use wood as well, guys. Even a 5 cm piece of wood is able to block the beta particles from penetrating through. So in your exam, as soon as you see the word aluminium or wood in regards to this radiation chapter, know for a fact that most likely it's going to be beta particles already. All right. Then finally, the last and most powerful thing is essentially going to be lead. Guys, you know, if you ever watch Superman, right? Anyone here a Superman fan? Yeah, it's Boy Scout nerd. But anyways, if you ever watch Superman, guys, you see the Superman, right? He will be stopped by only lead. You know, like, okay, let me tell you a little bit story. Okay, Superman is his arch nemesis is Lex Luthor, right? I think everyone knows that, right? Lex Luthor.
No lah, no.
And Lex Luthor. Then the Joker 打谁 Deadpool
只是 Lex Luthor。Lex Luthor 你不懂。
那个光头仔what the hell? Wait, I'll find it for you later on. Okay, but anyways, right, basically this lead follows a little bit scientific facts from Superman. You know, like Lex Luthor, every time he tries to hide from Superman, which has X-ray vision, this Lex Luthor will actually build a dome made of lead. Why? Because lead is the only thing that can stop everything. X-ray, gamma ray, blah, blah, blah ray, whatever ray also it can stop. So in your exam, guys, always remember that lead is the most powerful against all these forms of radiation. It doesn't matter if it's alpha, beta, or gamma. It's going to stop every one of it. Everything else will be basically penetrated through by gamma. Yeah, this lead. The most powerful tool. 可以写 all the information, 也可以 block radiation. Shit. Okay, but anyways, moving on. Right, so guys, always remember, guys, as soon as you see the word lead, most likely they're trying to talk about gamma radiation already. Yeah, very important, guys. Okay, now the next thing that we're going to talk about is basically the effects of an electric field. Guys, when we talk about electric field, what's the reason there is an electric field again? What causes the electric field?
What?
Did you just say corona?
Is it corona?
Say that. Hey guys, what's the reason? What makes an electric field? Anyone can remember or not? What makes an electric field? Of what? Not magnets. Magnet make magnetic field, bro. Electric field is from where? Electric current doesn't make an electric field. Magnet again. After magnet already, electric current and magnet. Hey, hello, charges. Remember not the positive and negative charges are positive and negative charges is the one that gives rise to electric field, which is very similar to magnetic field, right? Hey guys, even though it sounds ridiculous, guys, you cannot imagine how many times I've had students tell me electric field is from magnets already. Yes.
What's charge?
The positive and negative charges are like, oh, you know, the one that you have that causes static. You take a balloon and you rub against your hair, then your hair kind of gets attracted, right? It's definitely not magnets, right? That one, the electric static charges are, remember not? You know, like how thunder happens, right? You know, like thunder strikes and everything is because of the immense amount of negative charges that is struck down to the ground, guys, because they try to ground the negative charges. So thunder strike, every time you go to the shopping mall and try to hold your girlfriend's hand, you get a little shock. Definitely that's not magic, it's not butterflies as well, it's physics as well, it's the electric charges that are shocking you. If you're walking beside a friend, usually when you touch your forearm, you feel the electric shock as well, right? That is because of the charges as well, guys. Right. So how will alpha, beta, and gamma behave in a positive and negative charge? First things first is, as you recall, alpha particles are positive by nature and beta particles are negative by nature. So if, let's say, for example, I have a positive charge here and a negative charge here, you will definitely, pay attention to this. Everyone stop drawing. Pay attention to this. You'll definitely notice that the beta particles will be attracted upwards because it is a negative charge, and the alpha particles will be attracted downwards because it is a positive charge. But that is not the important part. The important part is if you look at the deviation, guys, do you notice that beta particles, which is obviously the pink color one, deviates more than the alpha particle? Deviate means to say it goes off course, right? Why do you think that the beta particles deviate more than your alpha particles? Very good answer. That is exactly the right answer. It is because the alpha particles are generally much heavier. It takes much more force to push them off course, whereas beta particles, these beta particles are very much lighter, right? So it's much easier to deviate them. So if, let's say, for example, if you were to push me versus you push Bishan, what's going to happen is I'm obviously going to deviate much less, right? Because I'm much heavier. And if you push this guy, because it's much lighter and smaller, it's easier to push him off course, right? So you can always imagine the deviation due to the mass, guys. The mass is the important thing. All right. Anyways, the final part here, guys, before you guys start drawing everything, is basically this. This is the most important thing in this chapter because everyone always don't understand what's going on here. Guys, if you look at this diagram here, okay, let me structure the diagram again, guys. So basically, right, in your exam, how would they ask you this? This is magnetic field. Just now, the positive and negative charge is the electric field, right? Right now, it's going to be magnetic field, right? If, let's say, the question says that the magnetic field, if the magnetic field is going into the page and they give you x axis like this, my question here is, where is the North Pole and where is the South Pole?
North is on top.
Like this, is it? And then South is at the bottom here, is it? Is it?
Yes.
If it's like this, the magnetic field is going to go down like this, right? Why do they bother drawing the XXX? No, it's not up and down. Where is the north and where is the south?
North is outside the paper.
If left to right, it will be this scenario, right? Bloody hell, it's the same thing, right?
North is outside the paper. South is
Very good. That's a very logical answer, guys. If they give you that the magnetic field is XXX, guys, it means to say that the north is in front of the paper and the south is right behind the paper, guys. Can everyone understand this? If you don't understand this, it's going to be hard, guys. Everyone understands, right? The north is in front here, the south is at the back of the screen. That's why the magnetic field is going into the paper. Yes, everyone understand, huh? Right. So if the magnetic field is going into the paper, usually, right, they'll give you questions like this. They'll say that, okay, right now I have an alpha particle that's shooting in this direction, and I have a beta particle that shoots in this direction. Is it going to deviate up or down, and why? Okay. It's gonna be. I'm not saying. this alpha particle and beta particle is either going to deviate up or down. Okay. Now, who here has any idea where will it deviate to? I think some of you guys have finished the syllabus, right? Why will alpha deviate up? Because remember the picture, don't know the reason. What was the reason? Nothing to do with like that. I don't know. I don't know where it's deviating, but I want to ask you guys right now, how do we determine? If guys think about it right now, this situation here, I want you to relate back with what we learned last week, guys. This situation here, we are given the magnetic field, right? Right. And we know for a fact that beta particles is basically an electron, right? And right now we're looking for the force that deviates it up or down. Doesn't this sound a little bit familiar with the magnetic field, the force? What? Someone said. What? Which hand? Why left? Why the left hand? It's correct, by the way. It's the left hand. Yeah, we're basically looking for the force. But if you recall back our Fleming's left hand rule, we needed two things to find the force, right? The first one was the magnetic field, which is given here. Okay. The second one is the current. How do we find the current given that the electron is flying on the other side? Left to right. Right to left or left to right? For the electron. Right to left. Good. Guys, if you're dealing with these kind of questions, first things first is you must understand, you must remember your basics, guys. In terms of a circuit, guys, we know for a fact that current will flow from positive to negative, right? Whereas electrons will always flow from negative to positive, right? This is the golden rule that we must remember to solve this kind of question. Remember that current flows from positive to negative and electron flows from negative to positive. Okay, from here, if we look at this situation here, if today the electron is flowing from left towards right, then which direction is the current? If the electron is flowing from left towards right, which
right to left.
Yes. So from here we understand that the current is actually from right to left. Okay. Once we understand that the current is in this direction, the magnetic field is in this direction, we can essentially use our Fleming's left hand rule, right? Everyone, tell me which direction would this be? Everyone, put up your hand right now and show me your right. Everyone, put up your left hand rule right now and tell me. Let me have a look at everyone. That's wrong. That is wrong. Hey, refer to this screen, So if anything, your magnetic field should be pointing like this, yeah? Refer to this screen so that I know I don't refer to your to the screen.
Yeah.
Bloody hell, you do like this. Like this. This is going into the screen. This is what? Father, mother, child, remember or not? Father, mother, child. So, everyone, I hope you all remember this, but the magnetic field is supposed to go into the screen, right? Then after that, your current, you always clench it into fist. Don't try to like, that is like, oh shit all over already. You point into the screen first, then you're looking for current, open your current finger, you point to that direction, then finally you know that the force is going downwards, right? Hey guys, for those who are online, guys, make sure that you have your magnetic field pointing into the screen, the current pointing towards the left, right? And then your force finger should be going downwards, guys. I repeat again, magnetic field into the screen, current finger towards the left, right? Maybe your camera might be a bit, what's it called? Laterally inverted already, but your force finger should be downwards. Okay. It's using the left hand. You're supposed to use the left hand because you're looking for the force. Okay, you're looking for the force, so you use the left hand. It may be laterally inverted because of the zoom setting, but left hand, magnetic field into the screen, current finger towards the left, and finally your thumb going downwards. Understand? Anyone online confused? It is very important. I've seen this come up multiple times in your IGs already, guys. Anyone don't know anything, like anyone don't understand what I'm talking about? Everyone here? Crystal clear? Very good question. Okay, so if we have identified beta as an electron, right? What usually we do is we associate alpha as the current reading, right? So we're assuming that this here is alpha and this here is beta already. So if alpha particles is being shot towards the right, using yet again your Fleming's left hand rule, magnetic field into the screen, the current going towards the right, and finally your force finger upwards, indicating that the alpha particle will deviate up, but the beta particle will deviate down. And yet again, you'll notice that the deviation of beta particles is much more because it is much lighter. Okay, everyone. Anyone don't know what I'm talking about? This is very important. Yeah. Okay, everyone understand? I'm going to give you a few questions. Everyone answer me this now. Anyone wants to take a screenshot of this or whatever? Let me just screenshot and send it to you later. Okay, guys, before we proceed on with this chapter, everyone tell me right now what's going to happen if I have magnetic field dotting like this. Right, what does dot mean again? Out of the screen, yes. And I have one alpha particles that shoots here, and I have one beta particle that shoots here. Tell me which way do they deviate? Everyone do it right now. While I go to the toilet. Everyone discuss among yourself. I want everyone to know the answer when I come back.
Oh, it's going down. No, I didn't go home. Oh, I didn't go home. I didn't go home. I'm sure that I'm money because I still live here. So the day I fly, I take
Your burn book.
don't burn your Malay book.
Why want to burn?
Nothing anymore.
Okay, everyone, I am Mark. So tell me, where will it deviate to? Starting from wait, yeah. Where will it deviate to? Up, down, left, right.
Left, beta right.
Alpha left, beta right. Who else? Right. Left, right. Alpha, beta. Beta right, alpha left. Correct. Where? Left, right. Alpha left, beta right. You alpha right, beta left. Beta is right, alpha is left. You Huh? Same like you? Same also. Everyone sheep mentality.
Both
Oh,
left.
both left. How many say both left? 三个. How many say both
I
right?
know it's both, but then I cannot move my finger.
Say go exam hall. Die already. How many say both left, both or both right? Both left. Both right,
It's both left.
Both right, both left.
Both left.
Then Marcus?
Both left.
Say everyone divided already. It's like the Fire Nation attacking all over again.
What were you? What's your answer?
I for sure know the answer. Which is whoever said left and right for sure wrong already.
Both left. Both left.
I remember it's both left or both right. Yet again, let's find out together, okay? Let's do the alpha one first. Yet again, if we have the alpha particle, guys. If we have the alpha particle, looking at this scenario here, first things first is you want to point your hand in the right direction, right? It's going to point out of the screen, right? And if you're pointing the hand out of the screen, this is essentially your current finger, right? So it's obviously supposed to go downwards, right? And when you go downwards here, opening up your thumb here, where is it going to go? It's going to go left. How about this one here? This one here is a bit tricky, right? Because if the beta particle is going upwards, the current is actually downwards here instead, right? So yet again, it is essentially the same thing as this thing, right? So it should go towards the left. Both of them must go towards the left. Everyone understand? It seems that I need to give you guys another question because almost, how many of you guys? This one. Everyone else do one more question. Hey, everyone, do the last one before we proceed on. Where will debate? Everyone, do your hand properly, guys. Okay, everyone. Out, left, right, up, down. Alpha is to the left, beta is up. Okay. Any other variation? I don't know. Do you have a variation or not? Anyone has a different answer? For sure, she's correct. What if she's wrong? And then the blind leading the blind, everyone die together. Yeah, let's go through it, guys. So yet again, this is magnetic field, right? You clench your hand into a fist first, right? And you always point inwards first. If you're doing the alpha, the current is going upwards, right? It means to say your force should be towards the left law, right? Right. So from here, beta is definitely going towards the left. But alpha is going towards the left. But for beta, yet again, magnetic field. Then the current this time is coming towards the right, right? Then it's going to go upwards. So this is going to be the left, this is going to go upwards. Did everyone seriously get that? Yes. This is very important.
Got it.
Excellent.
When you draw, like more like
yeah, must. When you draw the deviation of beta, always remember that beta will for sure deviate more than alpha because it's much lighter.
How do you draw it?
I mean, in this you can't lah, but if you draw, you draw. You draw like this, and then this one you draw a little bit. You draw a little bit long. I mean, you don't deviate that much. You're supposed to deviate lah for sure, but not as much. Okay? 大家明白了吗？ 100% absorption rate? Yeah. Yeah, copy this down and then we'll end the class now. Then we'll proceed with this next week.
Also, electric opposite
No. If let's say this is positive and this is negative, then obviously the beta will deviate here. Sorry, yeah, the alpha will deviate here, then the beta will deviate down here. So it depends on which direction is the charge. Get it?
Why won't the gamma like another reaction?
No charge.
And also can say because it's very fast.
Hmm?
You also say because it's very fast.
No, because it's just no charge.
So it's lead.
It's not fragile, it's layered one, you know. It's like if let's say I have this stick of lead, you try to punch it, you cannot punch one. But if you slice it layer by layer, you slice it layer by layer, it will come off one.
It was like a pin and everything.
Yeah. The theory
So, hello? Oh, okay. That mean you there? No. Something like to bike up.
Not that good. Sure. Yeah.
不用了，我功课等一下回去问一下。哦，还有啊。我要看他。
Yeah, it takes place when like wasn't even gone. Oh,
Heaven，好看吗？Shit movie 的嘛？What? Why?
因为
Tom Cruise 不帅，谁帅？
啊，帅到你看旁边观众把我。
别太子。
the Sunway that day we go Jurassic
Jurassic.
Just really come out.
I think we're gonna play like the whole day there though.
到5 o'clock 吗？
哇，5 o'clock 我就真的。哦。Jurassic Park.
Then the fetches all the way back here.
No, of course not. 自己搞掂喎，大佬。你们
来这边还是
No, just go there
Maybe
directly.
like rent a bus.
Of course not.
Why not?
Why not?
你们 rent a bus 哦，大佬。
Rent a bus 到我们那边走。
黐線啊 ！See you all there, man. Everyone tell your 爸爸媽媽，Hey, I'm going Sunway. No, definitely not. 我沒有住這邊的，大佬，我家在Sunway，那 like here to Sunway，你會經過到我家。黐線嘅，嚟。
Go your house overnight.
Yeah. Yeah, exit in, dots out. Hey guys, hurry up and copy this. I gotta go for a house viewing. House viewing.
Why you change how?
I'm renting somewhere else already. No, gonna be in. Look at Mutiara Damansara.
Wow.
So don't stay there for long.
It's right behind the turf park. IKEA.
走下家哦。
Sir,
Probably July.
your neighbor.
啊，你住那邊啊？
絕情
懶實地咁樣，唉。Okay, guys, everyone done copying this or not? 2 more minutes away, copy everything down. Just sketch it out, guys. You don't have to draw Picasso drawing, guys. But you need to know what's going on.
You say that, but also during the period.
Art is subjective.
Yeah. So like, don't draw like Picasso and like you gotta draw perfectly the.
Draw it according to your own liking. Something that you can be proud of. Okay, everyone, we're done drawing. Oh, sorry.
And so are you making plans to like hang this up?
Yeah, definitely.
And break down walls.
Break down walls, probably not it because it's too much.
Evan, are you guys seriously going to move the center?
People has been asking about it for a few times right now.
Where's the?
Maybe want to move somewhere closer to the LRT station. LRT or LRT station.
他们讲的地方是啥？
那么你们学校是LRT or LRT？
公主房少，不要放心讲的。
他才是有钱人。
有钱人啊！You see, it's just about money.
Okay, guys, done with copying today, guys. We'll continue this chapter next week, guys. Probably within the next 2 weeks, we should be able to finish the whole radiation chapter. Means to say by July, we're going to do revisions. August, we're going to do past year papers. September, we're going to do past year papers. And then October, everyone will be flying. October, how's that?
So you're gonna like reteach the whole way chapter.
Yeah, we'll definitely have it again. October, 应该是 somewhere middle of the month. Yeah, middle of the month. Okay, guys. If you have no questions, that will be it. Oh, by the way, guys. One more question to ask you guys. Anyone here thinking about graduating as a pilot? Like you want to graduate after your graduation, you want to go be a pilot? Anyone wants to be a pilot here?
Why?
Okay, why I'm asking about pilot is because I have a friend who recently opened up, not recently,
Pilot school.
yeah, a pilot school. And then he's asking me, do I want to organize one guy to talk about what's it like to be a pilot? Means to say they'll teach you to become a pilot and then you'll be a certified pilot.
So you have like 2020 vision.
2020 vision, no, I think they changed already. Yeah, anyone interested? Do you want me to get the guy to come over and talk about what's it like to be a pilot? I mean, there's definitely a few perks, right? The salary is crazy. You get to fly everywhere with a lot of beautiful chicks and guys. And guys, don't forget the girls. The guys and the girls are beautiful, right? And then you get to travel around the world, right? And it's paid for. Anyone? Anyone interested? No? Yeah, that'll be it for today, guys. Okay, yeah.
In his pilot school, you learn to fly planes.
Yeah, that's what a pilot school is.